In this problem, we have an array of measurable objects, and we're supposed to split it three ways: into an array of objects that are smaller than a given measure, equal to, or larger than a given measure. So there's an algorithmic issue here. So here I have my array, and what's in it is some objects of some class, I don't know which, but what I do know is they're all measurable. So each of them has a measure that I get by calling the getMeasure method. And I'm supposed to split this three ways, where the measure is less than some value, equal to some value, and then the rest where it's larger. As usual, I don't know how long these are going to be. So I have two choices. I could make these into arrays that are sufficiently long, and that could mean they're surely not going to be any longer than the input, so I could make 3 arrays of that. Or I could be lazy, and lazy is good, and I can just use array lists for here. So that's what I'm going to do. I'm going to be using 3 array lists. Array lists of what? Well, they're measurable, so I'm going to distribute these into 3 array lists of measurable. I simply pick up each of these elements in turn, visit one after another. Each time I'm going to call them measure, and depending on how they fall, I might put them here, or another one here, and another one here, just by calling add to the array list. That's simple. Now, of course, I have 3 array lists, and I'm supposed to be having 3 arrays. And as it happens, a kindly soul, namely myself, has provided you a method that turns an array list into an array, and you can just use that. So that's the algorithmic behind it. Now the rest is putting all of the various details together. So let's have a look at the various classes that we have here. We have the measurable interface from the textbook. We have this name class here. That's just an example of something that's measurable, to give a realistic example. And the measure of a name is the length of it. The length in the way that it's formatted here, with the last name, first name, middle initial. Here we have a tester, and what's significant about the tester is that it calls this method here, this data split name, it calls it with an array of names, which is one class that's measurable, and over here it calls it with an array of coins, so that's a different class, also measurable. So we're supposed to make the coin measurable. Actually, here is the coin class. And then the data, we have nothing, so we need to fill in the whole thing. So let's do these things one at a time. To make the coin class measurable, that really is pretty simple. We implement the measurable interface, and we provide the getMeasure method, where we just return the coin value. In the data class, here is the split method. Notice that split gets an array of measurables. It has no idea that they're names or coins. It allocates the 3 array lists. It walks through each of the items, and depending on whether the measure is less than, equal, or greater, it distributes those. And finally, it returns a new array of arrays that contains 3 arrays, the first, the second, and the last one, from this nifty 2 array method that I gave you. And that's all that's to it. The remarkable thing, once again, is that you have this method split here that has no idea what it's actually processing. It gets an array of objects of this interface type, it returns an array of objects of this interface type. All it knows about these things is that they have a getMeasure method, and that is good enough for it to do this kind of generic universal task. And then when you call it in the tester, you can call it over here with an array of name objects, over here with an array of coin objects. Same method gets called in two different contexts, and it just works.